Good morning, students. When it comes to the projection of planes, we have solved a first category of problem where normally we tell it in a general way. It is resting on one of its edge and the lamina is inclined and the resting edge is inclined to the respective plane. And whenever we come across problems with respect to the planes, already we have told in previous videos. Uh, the very first thing is to read the problem carefully from start to the end. Then we need to understand like where exactly the plane is resting and what is inclined to that respective plane and what is inclined to respective another plane. So now when it comes to the second category, here we have a set of problems where we will take up three problems which says one triangular lamina and one more a pentagonal lamina and one more an hexagonal lamina. So just to start with the first one, where we say there is a triangular lamina of side 25 resting on HP with one of its corners touching it, such that the side opposite to the corner on which it rests is 15 mm above HP and makes an angle of 30 degrees with the VP. So draw the projections and determine the inclination with respect to the HP they have asked. Okay, so even in the previous categories, we are told whenever we come across the planes, okay, the very first thing is the very first question we need to ask ourselves is where it is resting. Okay, so whether it is resting on HP or a VP. So here we get it is resting on the HP. Once we know it is resting on the HP, I said we will write it is HP and then VP. Okay, so now when it comes to the first HP, we'll be having a two option, whether it is resting on side or a corner. And when it comes to the second HP, so what is inclined to the HP? Then when it comes to the third option, that is VP, the third, what is inclined to the VP? Now, when we read this problem, we can clearly understand. So it is resting on one of its corner. Okay, then there is no inclination with respect to the HP. We need to find, and here the edge opposite to the corner, to the resting corner, is inclined to the VP. So these are the things what exactly we are going to find it here. Okay, so no inclination with respect to the HP, we need to find resting on the corner, and the edge opposite to that one is inclined to the HP. So such a problem, how to go with that one, we'll see now. So let's take up the XY line here, just copy that one to minimize the time. And now when we already know when it is resting on the corner, the median of a triangle should be parallel to the XY line. So now it is 25, enter, first is a 0, and again 25, enter, it is 120, that is 360 divided by 3, and again 25, enter, it's a 120 into 2, that is 240. So we'll get a triangle here. Okay, so that should be of 0.5. Okay, so once a triangle is done, we are supposed to ask like, is this satisfies resting on corner condition? For that one, what is needed? We need one median. So this is what is median is. Okay, so now that median should be parallel. How to make it parallel? We'll go to a rotate command, and keeping corner to the left one, we'll rotate it like this. Okay, so this is the resting corner condition. One that one is done, the very first thing is dimension and do the naming. So this is A, This is B, and this is a C. So after this one, so resta is the usual way where it is seen as a line in the front view. So project these things upward and it will be seen as a line in the front view. Let's change it. When it comes to the naming here, so this is A dash and this will be C dash in the bracket B dash. One that one is done. What is the second step? They are not given inclination, but instead of that one, they have given or they have given the such that the side opposite to the corner on which it hits is 15 mm above HP. Okay, so now when we see the problem here, this is the resting corner and this is the side. Okay, now when it in the front view, both are on the XY line. So let's say, like, if I move this line from here to the next position, okay, now both are equal. So now I need to rotate this one in such a way that keeping left hand here, the right hand should be 15 millimeter above. Okay, but here normally we get it in terms of a angle. Now how to do that one is there is a simple way where first we'll mark the line with respect to the XY line at a 15 millimeter above, that is 15 and 90, and just will drop one line like this. Okay, let's dimension that one because they have mentioned that in the problems. Go to the smart dimension, click on both the lines and drag it. That's a 15 line. Now the same line, this line, that means we need to measure the length of this line. That line measurement is 21.65. Now we are supposed to cut an arc on this line with respect to this distance. Okay, so we'll go to arc by center point. We'll keep it on the XY line and enter the radius as 21.65 press center and cut an arc across this line. Okay, now once that one is done, go to the trim option, trim the extra line and the extra arc. Now we got it. Now we can take a line 0.5. Okay, so from this end you join to the center of the arc. Normally the center of the arc will not be visible, but when you move on, say for example now, when I take a line here, if I move near to the arc, so the center will be visible. You can just drop it from here to here. Okay, now make this line 0.5, 0.1 and measure the angle now. Angle between this line and this line is the 44. That is the proper. Now move these navy here. The rest method will be similar to the type 1 problem. This is the only method which is makes a difference between the previous and this problem. Now take a projections now. Okay, so we can use a trim corner or alignment indicator. Any method is fine, whichever we feel is you can go for that. Now let's go for trim corner now. There is A is here, B is here, and C is. Now take a line, visible one, 0.5. So this is A to the B to the C to the A. Okay, now go to the move command, move the line, naming here A, this is B, and this is a C. Okay, now at the end, when it comes to third position, the edge opposite to the resting corner. Resting corner is A, and the edge opposite to that one is a BC. Okay. Let's move this uh, triangle. Now go to the rotate command and this vertical line we need to rotate in such a way that we should get a 30-degree here. That means we are supposed to give 90 minus of 30. Okay, so then we are going to get a required angle between this and this is a 30 degree. That is what is you are supposed to remember. Okay, so whenever we are rotating the vertical line, so we need 30 means here you are supposed to give 90 minus of a given angle. So now again go back to the move command. So move the naming here. Okay, so now project it upward. So this is A. A is on the XY line. So this is B. B is here. This is C. C is here. You can use any one of the method, alignment indicator or trim corner, depending upon the situation you use it. This is a three, just a three corner. So better we can go with the alignment indicator. Then things will be easy. So this is how exactly we are going to refer. You can say check it out like A is on the XY line. So on the XY line, it's only A. So let's take a move command. This is A, this is B, and this is C. And we need to mark a dash. A dash, B dash, C dash. Okay, so that's how exactly we can complete the problem. So rest and all will remain same. Only the thing is, yeah, in the second position, in the problem, they are specified the side opposite to the resting corner is 15 millimeter above the HP. Okay, so how to do that one? First of all, you need to take a that what are the distance 15 millimeter above. Then you will need to take the front view length, and you are supposed to cut an arc. Okay, so you are not supposed to just take a line and go on matching to that one. Okay, that's not a good way to finish the problem. Okay, so next remaining 25 and 20, 35 we'll take up in the next video. Okay, so in the similar way, there is a little change with respect to that one. So always for a few problems, you have an habit of writing these things. Okay, by reading the problem, then the remaining things will be fine here. So now the angle we got is a 44. That is nothing but a theta. So how to insert a theta here in the text command? There is a option called character map. When you click on that one, you will get one window like this. Okay. In this one, you are supposed to go back to the symbols here, and here you will get a theta symbol. Select is equal to is a 44, and here you will get a degree also. Select, okay, and copy, minimize this one. Again, here go back to the text, click here, and Control V. You will get everything like this. You just go back for the theta, just delete. Now, select this one and increase the font size. So this is exactly find this one. So theta is equal to 44.